This is Geometry, Unit 6 Review for Quiz Number 2. We're going to look here at this diagram, and we're looking for what triangles would be congruent to each other. We're trying to write a similarity statement. First of all, we need to recognize that the two triangles are in fact similar because they have one set of angles the same, and they also have the vertical angles the same. So we call that angle-angle, two angles of one triangle congruent to two angles of a second triangle. Angle-angle similarity. That's the reason these two triangles are similar. So we would name the first triangle, and they've chose to name it FED. So they started with the vertical angle, then they went down to the one tick mark, and then they finished at D with no tick mark. So we need to name the second triangle in the same fashion. Vertical to the one tick mark to the no tick mark. FRL. Similarity statement. This next set of proportions is a proportionality statement. It's another type of statement, but it's made with just the letters and their ratios. They're all equal to each other. Again, it's the same picture, so we have a pair of angles the same, a pair of verticals the same. The best way to figure out what makes these ratios is to look back over at your similarity statement. The first two letters, FE or EF, go with R and F. The second, or the first and last letter, F and D, go with F and L, first and last letter. The L and R, the last two letters, go with the E and the D. So that would be a proportionality statement. Now we can practice this. We can write a proportion to see what the values of X and Y are. So first of all, we know the triangles are congruent because they both have a one ticker and a two ticker. So that's called angle-angle similarity. That's why the triangles are similar. You can't write these proportions if the triangles are not similar. So now, across from the one tick mark is the 14. Across from the one tick mark is the 5.6. Now, since we started with the 14 on top, I have to start with another value from this left triangle. So let's start with X. X is in between the 1 and 2 tick mark, so that means it's going to be 7.2. A couple different ways we could try to solve this, but the obvious way is going to be to cross multiply. Notice that I just multiplied the 7.2 with the 14. I didn't need to cross multiply the other direction because we want the 5.6 on the bottom. So 14 times our 7.2, that gives us 100.8 divided by 5.6. And when I divide that, you could use your calculator to show that you know how to type it in, but X is going to become 18. The Y value, we're going to have to set it up the same way. We'll use the numbers 14 and 5.6 because those are the corresponding sides that both have numbers. And then the Y is across from the 2 tick mark, and the 8.8 is across from the 2 tick mark. Notice that the 14 and the Y come from the same triangle. So they're both on the same side of your proportion, meaning both on top. They're both the numerator of your fractions. So we'll cross multiply. 14 times 8.8 gives us 123.2 divided by our 5.6. And that comes out to be 22. Here, we first need to determine if the triangles are similar, and then if they're similar, we're going to write a similarity statement and give one of the three different ways that we can show triangles similar. So here we have 45, that's the same, and we also have a pair of vertical angles. So the answer is yes, they are similar. Why are they similar? Because of the angle-angle similarity. Notice I didn't use side, side, side because I don't know any side measurements. I didn't use side, angle, side because I don't know any side measurements. So if you're looking for the postulate or theorem, we'll just call this would start out to be the postulate, but we'll just place it in here. We use the word similarity to remind us what we're talking about. Since they are similar to each other, you can name the first triangle any way you want. MSU would be a good way. M was the no tick mark. S was the 2 tick mark. So OSE. So looking down here, are the two triangles similar? Well, to be similar, I have to be able to show them similar one of 3 ways. Either by angle-angle, and I only know one set of angles here. Side, 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 but I only know 2 sides of each triangle. I don't know 3 sides of each triangle. Or side, angle, side, and that's kind of looks like what we have here. We have 2 sides and the included angle. But notice right away that that included angle is not congruent. Angle S is not congruent to angle H. So, no, they are not similar to each other. So there's no need, there is no similarity statement because they're not similar to each other. There's no reason for that, no theorem, because they're not. This one, again, we don't have the 3 sides, we don't have 2 sets of angles, we only have this one set of angles, and we know that vertical angles are always congruent. Now we have to look to see if the sides are proportional. So I'm going to take the small side of one triangle and compare that with the small side of another triangle. We can reduce that. It looks like 7 goes into both of those. And then I can take the 18 and the 27, and it looks like a 9 goes into both of those. And yes, they both reduce to the same amount. So yes, the triangles are similar. And we did that by side, angle, side similarity. So you can name your first triangle any way you want. So let's start with CLW. Now the C came off the longest side, so that would have to be NOW. So with these triangles, we need to determine which of these triangles is similar to triangle ABC. Well, we're going to start out with triangle ABC. ABC started with, when I said AB, that was the medium side of the 3 numbers, then the long side, and then I finished up coming back to make a triangle. So when I think about how the other triangle is going to be named, I have to go down the medium side, then down the long side, so JKL. So it's important that we write the triangles and look at their information in the correct order, in corresponding order. So we're first going to look for our numbers that set this up. So the AB is 8 and the JK is 18. That looks like that reduces by 2 and reduces by 2. we can look at the 12 and the 27. 3 goes into this guy, and 3 goes into that one. And then our last set, which is the 6 and the 13.5. Now 13.5, that's kind of hard to work with. I can't reduce that quite as easily. So let's multiply both of these by 2. That's going to make it 12 over 27, which is the same as this. They reduce by 3, and they're 4/7. Every fraction here reduces to 4/7. So that's a way to figure out the scale factor. They all had to reduce to 4/7. Not just one of them, but all of them. It didn't matter what they reduced to become, but they all had to reduce to the same fraction. So how are we going to show? Oh, we're going to write a similarity statement, and that would be triangle ABC is similar to triangle, I've already taken time to figure out the correct order, JKL. And just for fun, we did that by side, side, side similarity. So yes, these two triangles are similar to each other. Let's take a look at what happens here on this side. Triangle ABC and triangle down the medium side, the long side, RST. So we're going to say 8 over 12. That could reduce by 4s. And then 12 on the bigger side is 18. That can reduce by 6s. This reduces to 2/3. This reduces to 2/3. And then our longest sides, or actually the shortest, would be 6 and 9. And again, that reduces down to 2/3. All fractions reduce to 2/3 in this case. All the sides. So the triangles are going to be ABC is similar to triangle RST for the same reason. Side, side, side. Similarity. Looking at the flip side now, we're going to look at this figure, and we're going to use this ratio. Given this ratio, this says that RS, when this triangle gets bigger, it becomes RU. It kind of flips over here. So the 1 is going to become the 3. This triangle is going to get bigger, and it's going to land over here. And we also know that RM, what is this side, is going to become RD, which is this side. So we're looking for the information. Which statement down here is true? Is angle 1 and 2 congruent? Well, if the lines were parallel, they would be. But if the lines were parallel, then it would get bigger in the correct direction. And the typical direction of RS becomes RD, but that's not the way they have it. So that does not work. The lines are not parallel. We don't have that information. 1 and 4, we don't know that the sides are necessarily congruent for base angles to be congruent. So we don't have that information. RSM and RUD. That sounds right. We put R, then down to the 1 tick mark and over. From the R to the 1 tick mark and over. So that is the correct answer. That's the true statement of all these. It's kind of tricky. You need to read each one and try to give an explanation, at least in your head, why that doesn't work. You'll see some of those on your midterm also. So we're going to show the triangles are similar. Remember, we have 3 ways to do that. So first we're going to look here, and we see that they both have a 90-degree angle. They both have vertical angles. So we have shown that these triangles are similar, and the method that we did that in is angle-angle similarity. So now we have to look for a scale factor. That means I got to find some sides that I can relate together. From the 90 to the vertical and the 90 to the vertical, we could call that 4/9. It says smaller triangle to the larger triangle. So now we know that we're supposed to put the 4 on top and the 9 on bottom. Smaller to larger triangle. Solve for x. So I know that the 4 becomes the 9, therefore the 5 becomes the x. The 4 is the long leg, the 9 is the long leg. The 5 is the hypotenuse, and so is the x. The 9 and the x are of the same triangle, the 4 and the 5 are of the same triangle. So here we need to cross multiply both directions. That's going to go in there 11 times with 1/4 left over, or 0.25. And those would be called units. We're not sure if they're inches or centimeters. We'll just call them units. Number 10. Number 10, first, for us to find AD, we're going to look for this full length. We first have to determine, are the 2 triangles similar to each other? So we're going to look here, and I see that the 80s are both the same, and both triangles have angle A the same. The small triangle has angle A, and so does the big triangle. So of course, that's the same measurement for both triangles. So we know the triangles are similar by angle-angle. So I could say that triangle ABC is similar to triangle ADE by angle-angle similarity. Now I can write my proportions. AB, first 2 letters, over AD, that's the one we're looking for. BC, which is another number that we know, over DE, last 2 letters, last 2 letters. So we can plug in our numbers. You could reduce these fractions, or you can just cross multiply the way they are. So we get 72 equals 8x. Divide. We got 9. So AD equals 9 centimeters. Okay, I actually wrote x. I guess x isn't even in my equation. It's AD. So in this case, that would still be AD. That would be the correct way to have it written. Last question. Here we have a flag on this side, I guess. Here's our flag. It's 28 feet high. Has a shadow. If the sun is up here, that's the sun, not a cloud. If that's the sun up here, it's making a shadow come out. We have a tree that's definitely taller, and its shadow measures longer. This one measures 4 2/3 feet long. So that means the sun is pretty high in the sky. And this shadow is 12 feet, so considerably longer. So we're going to write the tree height over the pole height is going to equal the tree shadow over the pole shadow. That might help you in terms of knowing how to set up your proportion. The height of the tree is what we don't know. The height of the pole is 28. The shadow of the tree is 12. The shadow of the pole is our 14. We'll call that 14 thirds. Now, that's a little tricky to work with, but we could just cross multiply if we want. Might make things a little bit easier. 14 thirds times h equals 12 times 28, which is 336. If we're using a calculator, we might as well use the big numbers. Or you could reduce, but not real easy to reduce in this case. So now we're going to multiply by 3. 14h, and that's 1008, and divide by the 14. Notice I did not turn this into a decimal. And that comes out to be exactly 72. So it's 72 feet. Feet are the units. So the tree height is 72. Good luck.